So I want to show you how you can find the shortest distance between two skew lines. So skew lines, right, are out here in 3 space, and they're not parallel, they're not perpendicular, but they never intersect. Okay, so they're on like different planes. Right? Okay, so something you should know, right, the shortest distance between, right, these two skew lines is going to be that line segment that is perpendicular to both of the lines. Right? So we're going to use some stuff we know about vectors and cross products and what that means about being perpendicular to help find that line segment. Okay? So what our strategy is we're going to think of these two lines, right? We're going to think of the planes, right, that contain the lines, and then the two planes are going to be parallel to each other. Right? So go ahead and grab a couple of pens or something and imagine them out in space. Okay. And imagine that you could find a plane through each of them, and then each of those planes is going to be, right, parallel to each other. Right? So for the way that I have mine drawn here, or the way I'm holding them, right, I'm going to go ahead and drop this one down in. Okay. So I would have one plane here, right, and then the other plane parallel to it down here, right, that also contains that line that's on the bottom here. Okay, so here's how we're going to do it. We're going to have u be the direction vector of L1. V is going to be the direction vector of L2. And then if we find u cross v, we're going to let that be n for the normal vector. Right? We know that n is going to be perpendicular to both, right, u and v. Right? And u and v are the direction vectors of L1 and L2. So we are getting that, right? We're getting a vector that's in the perpendicular distance between the two lines. Okay, so there's step one. And now we're going to come up with this new vector b, and it's going to be any vector between my two lines. Okay, so we're just going to find some random vector b that goes between a point on line 1 and a point on line 2. Okay, so then the shortest distance is going to be the length of the projection of vector b, that random vector between my two lines, onto that normal vector that's perpendicular, right? Okay, so let's go ahead and do that. So here we go. Here I have two random lines, and they're written just here in parametric vector form. So u, so the direction vector for L1, remember that's just this, think of it the slope, right? It's the one multiplying its parameter. So -4, -2, 4. Right? And vector v for L2, so it's, and notice I've used different parameters because they don't have to step at the same rate, right? So t is my parameter for L1 and s is my parameter for L2. They're just, s and t, those are the common ones that we use. I don't know why. Okay, so there's my u and v. So now let's find n. So we'll just use our matrix here. And u and v. Okay, hopefully I won't make an arithmetic mistake in here. If I do, correct it on your own and trust that, right, if you were here with me, you could holler out at me and I would hear you. I won't hear you if you holler out at me this time, but go ahead and holler. It'll make you feel better. Okay, so my new n vector, so in the i's, I'm going to have 2 minus 4 minus j, and that'll be 4 minus -16, so plus 16. And then k will be -4 minus 8. Okay, so I'm going to go ahead and take it back to my other vector notation here. So I'm going to have -2 in the I, -20 in the j, and -12 in the k. Okay, so I have my n. Now I need to come up with this random vector, right, b, that's between any point on L to any other point on, or L1 to any other point on L2. Okay, so what's a point that you know is on L1? Right? So a point, right, is just that other vector, because, right, you could find a point by plugging in different values of t, and that gets you the different points along the line. So if we let t be 0, right, one of the points on the line is, right, 9, negative 1, 0. Okay, so a point on L1, so L1 point, is going to be 9, negative 1, 0. And an L2 point, right, same idea, 7, negative 7, 0. So let's find the vector between those two lines. Okay, so vector B, so 9 minus 7, negative 1 minus negative 7, so that'll be negative 1 plus 7, and 0 minus 0. Okay, so there's my vector B. So what is the projection of B onto N? Okay, so I'll bring this back from right before. So the projection of B onto A is A dot B, right, divided by the length of A squared, and then it's in the A direction, right? So the projection is actually a vector. I don't really care about the vector. I just want to know how long it is, right? So I want the length of the projection. So if you think about how that would work from here, right? So that means I'll have, so A dot B, that's already, I'm going to put absolute values on that. A dot B, that's already a number. Okay. And then if I take the length of A, right, one of these lengths of vector A is going to cancel this length of vector A squared. So if I'm just looking for the length of the projection, which I am, okay, then I'm just going to do A dot B, make sure you do the absolute value so it's positive, and then divide that by the length of A. But in this case, A is being played by vector N. Okay, so I need N dot B, and then I need to divide by the length of vector N. All right, so here's my N vector, and here's my B vector. Okay, so N dot B, we're going to do the absolute value of that. Get all my symbols in here. So I'm going to get negative 4, minus 120, plus 0, divided by, now I need the length of N. So square root of negative 2 squared, plus negative 20 squared, plus negative 12 squared. Okay, oh, sorry, thank you. So my distance between those 2 points is equal to, is that 124 absolute value, so 124 over the square root, what is that, 548. Okay, I can tell you guys want to simplify that. So let's see, 548. It's okay if you don't. You could leave it here. You could find a decimal version if you wanted. So 548 divided by 4 for sure. So that's going to be square root 4, square root 137, 124. Square root of 4 is 2, and 124 divided by 2 is going to be 62 over square root 137. Final answer.